going to solve number 6 and number 7 for you, or simplify them, I mean, from yesterday's set of complex fractions, section K, numbers 4 through 7. Number 4 was very easy. Number 5 I did in class, so we're going to discuss number 6 and 7 up here. So if you have questions on those, check as you go. Number 6, we had x to the negative 1 plus y to the negative 1 all over x plus y. So first thing we need to do is we need to deal with our negative exponents, and which means I need to take the reciprocal of those. That's what to the negative 1 power means. So I have 1 over x plus 1 over y all over x plus y, hence creating a what we call a complex fraction, a fraction within a fraction. So our task before we simplify this is to go to the top, and we need to get a common denominator. We can see that our common denominator is going to be x times y. So this one needs a y, as does this. This one needs an x, as does this. Or like I told you in class, you can do that crisscross and go across. Either way, you're going to end up with y plus x on the top once you've simplified over xy, and then that's all over x plus y. Okay? So, oops, I forgot just 1 second, I forgot. I said it and I didn't write it down. So I have y plus x over xy created from this simplification right here, and then it's still all over x plus y. And remember we talked about how in class when you have a fraction just over a whole number like this is really just 1 over 2 times 3, because this would be a third if you did the reciprocal. So what happens here when I'm doing y plus x over xy, and then I do the whole thing over x plus y, then x plus y is actually down here on the bottom. All right, which is going to cause these to cancel, which leaves me with my final answer, 1 over xy. There are a couple things to mention in here with the details. I've given you a couple little shortcuts, but make sure you use them correctly. So if you hadn't gone about this process for getting your common denominator and you used the shortcut I gave you in class, remember that'd be 1 times y, which is y, over 1 times x, which is x, over xy, thus creating this portion of your fraction. Also, when you divide by a single quantity like that, so like over here again, when I have a fraction divided by a whole number or whole quantity, that really is down here, and it's really 1 over 2 times 3. Make sure you understand why that is. Again, I showed you it right here. It's because we take the reciprocal of the 3, which still keeps it on the bottom, which is why this remained on the bottom. And then my canceling occurred and left me with my final answer. So that was number 6. Number 7 was x to the negative 2 plus x to the negative 1 plus 1 all over x to the negative 2 minus x. So again, let's deal with the negative exponents first, giving us 1 over x squared plus 1 over x plus 1 over 1. I think it's good for you to always write those as fractions. And on the bottom, I have 1 over x squared minus x technically over 1. All right, so now we have to go tackle the fact that we need to simplify both the top, which I'll do in red, and the bottom, which I'll do in blue. So I'm going to ignore the bottom or the blue part, and I'm going to go clean up the top. Now, for this one, my common denominator between x squared, x, and 1 is actually x squared. So I need to write them all with a denominator of x squared, which will leave the first one untouched. The second one, I need to introduce an x. So I'm going to get x over x squared. And my third one, I'm going to need x squared and x squared. So I'm going to get x squared over x squared. Again, just simple adding of fractions requiring a common denominator. Same thing on the bottom, but again, you might notice that we've got that the LCD here is actually just the product of these two. So again, I can do 1 minus x cubed all over x squared. Should have done that in blue probably. I'm going to go over it in blue. 1 minus x cubed all over x squared. All right, so now doing a little cleanup here. On the top of the fraction on this red part, I have 1 plus x squared, everything over x squared, And then likewise on the bottom, I have 1 minus x cubed all over x squared. Again, I could multiply by the reciprocal, but when I flip this one over, the x squared is going to go up to the top and cancel. And we talked about how that skipping a tier like that causes those to cancel. So on the top, I'm going to write this in more standard form. I have x squared plus x plus 1. On the bottom, 1 minus x cubed. So that's what I'm really left with. If you left it right there, you're not done. We've got ourselves a difference of cubes down there, and although you don't really need to memorize how to factor a difference of cubes, I never saw one pop up on any of the AP exams. They do pop up in your homework quite a bit. So you might want to write the models down for them, or be able to create them. But when you have a difference of cubes, you can pull out the a minus b, and then it's kind of like undistributing. To create that a cubed, I'm going to need an a squared, right? And then also on the inside, it's plus ab and then plus b squared. If you were to distribute this, you are going to get a cubed minus b cubed, all right? And if it's a sum of cubes, and you don't really need to memorize this, just, have a place, maybe we'll even put it in your calculator. A plus b, again, we end up getting an a cubed, but then we get a minus ab plus b cubed. So let's go down here. For me to factor this on the bottom, again, I pull out a minus b. In this case, it would be 1 minus x. And then I need to multiply it by 1 squared plus 1 times x, and then plus x squared. And again, I'm just using this model. If you forgot your difference of cubes, just go ahead and copy that model down. And then on the top, I have my x squared plus x plus 1. You'll note that these are going to cancel, leaving me a 1 over 1 minus x, which is the simplified version of this. Now note the power of this. Again, this is all the algebra, but perhaps in chapter 1 you'll be asked to take the limit of this as x approaches 0. In this form, you can't do it because that would be undefined, undefined, undefined. You have a lot of issues. But once it gets all simplified down to here, now when I have my limit as x approaches 0, I can just put that 0 in and my answer is 1. So although, and again, we're not working with limits right now. I'm just working on getting this algebra cleaned up, but just so you understand where it's going. So the answer to this one is 1 over 1 minus x. And I am done. See ya mañana.